Imagine braking from a speed where every fraction of a second matters. And then imagine the brake system itself becoming one of the biggest technological battles on a superbike. This is the 2027 BMW M1000RR. But today we're looking beyond the horsepower numbers. We're investigating something far more interesting. The possibility of advanced carbon braking technology combined with a new approach to thermal management. BMW already uses sophisticated brake cooling and aerodynamic engineering on the M1000RR. But could the next step be liquid cooling? And if it is, what would that actually mean for braking performance? Let's take a much closer look. From the side, the M1000RR looks almost like a machine designed around one single purpose, going faster while staying under control. The proportions are compact. The bodywork is heavily shaped by airflow, and the carbon components are not there simply for appearance. BMW has engineered this motorcycle around racing performance, and the current 2027 model is officially listed with 218 horsepower and a claimed 314 km/h top speed. But at this level of performance, going fast is only half the equation. Stopping consistently becomes just as important. Now look at the front. This is where BMW's aerodynamic philosophy becomes obvious. The winglets are designed to increase front-wheel load, helping the motorcycle remain more planted when acceleration and cornering forces become extreme. BMW says the current M winglets can generate up to 22.6 kilograms of downforce depending on speed. And around the front wheel, the airflow becomes even more important because this is also where BMW integrates its M-brake duct system. And this is where our investigation gets interesting. BMW already uses carbon brake ducts to direct cooling air toward the calipers. The purpose is simple: control heat and maintain a more consistent braking feel during intense track riding. BMW states that these ducts can reduce brake caliper temperature by up to 10 degrees Celsius depending on the racetrack. But notice what BMW has actually confirmed. This is an air cooling system. The idea of a liquid-cooled carbon brake system is a different question, and BMW has not officially confirmed such a production technology for the 2027 M1000RR. So what would liquid cooling change if engineers actually brought it to a carbon-based braking system? In theory, the attraction is obvious. Liquid can carry heat away very efficiently, potentially giving engineers another way to manage extreme thermal loads. But there is a major engineering challenge here. A motorcycle brake system has to remain incredibly light, mechanically reliable, and compact. It also has to survive repeated thermal cycles, vibration, and massive braking forces. So this is not a feature we should simply assume exists. It is better understood as a fascinating direction for future performance brake development. Carbon appears again in the wheel itself. BMW's M-carbon wheels are designed to reduce weight and rotational mass while maintaining high stiffness. That matters because every gram saved here can influence acceleration, braking, and handling. And when you combine a lightweight wheel with a high-performance brake system, the result is not simply a lighter motorcycle. It can change how quickly the bike responds to steering and braking inputs. Of course, the braking system is only one part of this equation. The M1000RR is built around a 999cc liquid-cooled inline-4 engine, and BMW's 2027 model information lists 218 horsepower. At these performance levels, every acceleration zone is followed by a braking zone, which means the more aggressively the engine pushes the motorcycle forward, the more demanding the braking system becomes. Then there is the aerodynamic side of the story. BMW's latest MRR uses redesigned winglets to increase downforce, including while the motorcycle is leaned over. That means the goal isn't simply higher top speed. It's better front-wheel confidence, stronger stability, and reduced wheelie tendency when the rider is pushing hard. And this is exactly why braking and aerodynamics cannot really be discussed separately on a superbike like this. This is where all the engineering finally has to work together. The engine creates the speed, The aerodynamics help keep the chassis stable. The tires provide the contact with the track. And the brakes have to convert enormous kinetic energy into heat, repeatedly, lap after lap. That last part is the hidden battle. A brake can be extremely powerful, but if heat changes its feel or consistency, the rider loses confidence. That is why thermal management matters so much. BMW's current solution is actually quite clever. The brake ducts are integrated into the front wheel area, helping guide cooling air around the fork legs and brake calipers. It's an aerodynamic solution and a thermal management solution at the same time. And that is the important clue here. On the M1000RR, BMW increasingly treats airflow as part of the braking system itself. From the cockpit, this entire system becomes the rider's responsibility. Every brake input has to feel predictable. Every change in grip has to be communicated. And modern electronics are constantly working in the background to help the rider manage that performance. But the goal isn't to hide the physics. The goal is to give the rider enough confidence to use more of what the motorcycle is capable of. Put everything together, and the M1000RR starts to make more sense. BMW has officially focused heavily on aerodynamics, downforce, rider airflow, and brake cooling. The current 2027 model is listed at 314 kilometers per hour, so this isn't engineering for a casual Sunday ride. It is engineering for a motorcycle operating in an environment where aerodynamic drag, heat, braking stability, and tire contact all become critical. And now we come to the question behind this entire investigation. Could liquid-cooled carbon brakes become the next major step? Technically, there are interesting possibilities, but there are also huge challenges. Weight, packaging, reliability, temperature management, and manufacturing complexity. Until BMW officially confirms such a system, we should treat it as a technological possibility, not a specification of the production motorcycle. So, what have we actually discovered? The 2027 BMW M1000RR is already an extremely advanced superbike. With 218 horsepower, a claimed 314 km/h top speed, sophisticated aerodynamics, and a brake cooling system designed specifically for extreme performance. But the liquid-cooled carbon brake technology remains something we should investigate rather than call confirmed. And honestly, that may be what makes this story even more interesting. Because BMW has already shown that airflow can be used to cool the brakes, stabilize the motorcycle, and improve performance. The next question is simply how far that engineering philosophy can go. Because if BMW eventually manages to combine carbon braking materials with a truly advanced liquid thermal management system, we may not just be looking at a better brake. We could be looking at an entirely different way of controlling heat on a superbike. And that raises one final question. How much faster could a motorcycle become if its biggest limitation was no longer heat?